I'm a zero-install developer. Last year, I spent about 7 months converting zero-install from Python to OCaml. And today's talk is going to be a quick introduction to zero-install, and then some of the things I found out and my experiences as a new user of OCaml. So I should say, zero-install is a decentralized cross-platform package manager. Decentralized means we don't have any kind of central repository. It's not like OCaml or Debian. It works like the web. Every program and library has a URL, and the system will go out into the web and pull down programs and their dependencies, solve them, and then download the actual executables. Cross-platform means we work on all versions of Linux, Unix, OS X, and Windows. So you can make one package and have it work everywhere. And by package manager, I mean we support the same kind of things that you would get from a Linux package manager. So digital signatures, checking hashes, automatic updates, upgrades to testing versions, rollback, library handling, that kind of thing. To give you an idea of where it came from, in 1999 I was building a Linux desktop environment called ROX. And we had lots of applications, lots of releases, some libraries, and we found it quite hard to get these to our users, who were Linux users and they expected some kind of package manager to deal with this for them. So naturally we tried making distribution packages. But it had a few problems. First of all, you've got lots of different packaging formats that you need to support. You need to make a Debian package, Red Hat, SUSE, Arch, and so on. You generally find that every distribution packager packages it slightly differently. The Debian package maintainer, for example, they changed the name of our executable. So all of our documentation then was wrong, all the other programs didn't work with it. Most distributions package some bits of it and not others. So you have to tell Fedora users, sorry, you can't use this program, Fedora doesn't have it. And even when everything is packaged, the distribution cycle is really slow. So it's a great default if the distributions say, here's some stable software, we recommend this version. But it doesn't work for everyone, and if it's broken for you, we really want to be able to say, just click here and try the latest version. Not you're stuck on this broken version for the next 6 months. So to try and address these problems, I started zero-install in 2003. You create one package format. Well, it's not even a package format, really. It's you release tarbles, zip files, exactly what you would release if you weren't using zero-install. If you describe it, you put up metadata on your website saying which versions are available, what they depend on, where to download them from, what their hashes are. Zero-install will not make your software magically work on multiple platforms. It's not virtualization, although you can use it with virtualization. But if your software works on multiple platforms, you only have to make one package to describe it. The packages themselves in zero-install can still come from the distribution. It doesn't override them, it doesn't bypass them. If the distribution prefers a particular version, zero-install will default to that version. But if a distribution doesn't say anything about your package, then the default is to go upstream and give you the upstream package. And finally, we make it really easy to upgrade. So if you want to change your policy and say, no, I don't want the latest stable release, I want the latest release full stop, zero-install will get you the latest release, and it will get you, if it depends on new libraries, it will download all of those libraries too, and it will use those new libraries with that program and without affecting the other libraries on the system. So everything is scoped to a single package, making it very easy to have stable software and testing software at the same time. So now I don't try and get my software into Linux distributions, I just get zero-install in, and there are packages now in every major Linux distribution, and they have been there for several years. You can generally just say install zero-install-injector, which is usually the old Python version, or zero-install with digit, which is usually the new OCaml version. They are entirely compatible. We also have packages for OS X and Windows. So when I started at Cambridge, one of the things they asked me, I gave a demo of zero-install when I started, and they said, can we use it for something like OCaml, which is, it's a bit strange having, using a package manager to install the zero-install package manager and using the zero-install package manager to install the OCaml package manager, but it's still easier than doing it manually. So here, if you're on a Linux system, you should be able to say install add OCaml tools.ocaml.org/ocaml.xml, and it will go to the OCaml website and download information about available versions of OCaml. It'll discover that it depends on curl to download things, and I don't know how you pronounce this, ASCII, a solver for resolving constraints. And in this case, I'm on Fedora, and it said, okay, I can see there's a native package of curl available here. Curl's already installed. I'm just going to use that. But for the solver, it said Fedora doesn't have an ASCII package, so I'm going to download that from its website. And once it's done, you can just use OCaml as per normal. If you're like me, you're probably quite curious about where these things go. Is this going to mess up my system? Is it going to conflict with things? Is it going to overwrite files? You can say 0install show OCaml, and it will tell you, okay, I downloaded OCaml 111, and I put it in your home directory under .cache/0install, which is where all software goes. And in particular, it's gone into a subdirectory named after a hash of its contents, which means that 0install packages can never conflict with each other. You can just parallel install any versions at all. Every file will go into a separate directory. And you can see likewise the solver ASCII has gone into a separate directory, again with its own hash. And in fact, if I actually type ASCII, I ask to run it, my shell will at this point say, command not found. Because I didn't tell it to install that, I only told it to install OCaml. It's only installed the launcher for OCaml. Everything else is just sitting in the cache, ready to be used when I run OCaml. To upgrade, you can, so by default, 0install prefers stable versions, as I say. If you ask to upgrade OCaml, it'll say, okay, there's a 1.2 beta available, but it's currently marked as testing, so I'm not going to use it. If you're a Debian unstable user or an Arch Linux user and you like to live on the edge, you can say, globally change my policy, I always want the latest version of everything. Or if you just need this particular pro version of OCaml, you can add a constraint. You can say update OCaml and add the constraint not before 1.2 beta 4, and then it will download that version for you. A really nice feature of being able to parallel install things is you can actually, if things break, sometimes you upgrade a package and it stops working and you want to know why, you can say what changed OCaml, and it will tell you when it last updated it and what the changes were. And in this case, it's saying, well, that should the OCaml binary itself changed its version. It would also track changes to any libraries it uses. And if you suspect this is the cause of your problems, you can just run this command, and it will actually run. You can say, okay, I want to run yesterday's version of OCaml, which is working with yesterday's version of ASCII. And you can quickly see whether that was the problem. And finally, if you want to publish your software, what you put up a web page. The web page is what versions are available, where to get them. It gives links to their dependencies, exactly as you would do if you weren't using 0install. The only difference is, instead of writing in HTML, you're writing in XML, and typically we use a style sheet so it appears as a nice web page. I know some people don't like XML format, but it's pretty straightforward. And at the end, of course, the main difference is there is a digital signature on the page itself. So 0install is able to check that updates come assigned with the same key, and it can check with a central key server to make sure that there's some root of trust here. So that's just a quick introduction to 0install so you can understand the rest of it. Any questions quickly about 0install?
How does it deal with shared library? Is anything shared?
Yes, everything's shared. Because it uses hashes, if something else also depends on ASCII, for example, and it also wants the latest stable version, it will also select that same version, probably, almost certainly, and it will see, okay, this is the hash I want, it's already on the disk, it will share it. You can also, there's a helper program which will actually copy this into a system directory, var/cache 0install.net, if you want to share between multiple users. So they don't need root access to install because the shared helper is checking the hashes, but they can still share automatically the software. Okay. Yeah?
Do you have to rewrite that inside binaries like Linux people need to do?
No, we strongly encourage you to write relocatable binaries. We don't do that little trick. We could do that, but people propose various hacks, but personally I just prefer to make things relocatable.
Maybe to follow up on this question, comparing with Nixos,
unique software when I run a program that has a particular cache, I'm sure it comes with a particularly well-defined configuration to go through all the details like in Git, where you get the details. What happens in your case?
So here we're more like a Linux distribution. We allow packages to be upgraded, and if something's not binary compatible, then it needs to say that explicitly, which you can regard as either a problem or as an advantage. It's just a point of view, really. Yeah.
Can I have a package that supports, let's say, multiple versions of OpenSSL? Let's say I build one for OpenSSL 1.0 and another one for OpenSSL 0.9 because they are not API compatible.
Yeah, exactly. So you publish that as two binaries with two different dependencies with different constraints. And then 0install will look at which one your distribution has available, and it will pick the appropriate binary for your system.
Okay.
And we do that already, for example, with Python. So where some binaries are compiled, some libraries are compiled for Python 2 and some are compiled for Python 3, and it will choose the right one for your system.
Can I also look at the libc version on the system to know which binary to choose?
In theory, but in practice, libc is very compatible, and we don't provide a package for that. We just assume it's there. In general, we only put in the dependencies.
I mean the version number, because if I run it on an older libc, it won't run anymore.
Yeah. Yes, you could do that. Generally, we just compile on a very old libc, if possible, usually in a Docker container, to try and just make it as compatible as possible. Okay, so originally 0install was written, believe it or not, it was a network file system written as a Linux kernel module in C, which turned out to be really hard for people to install. So in 2005, it was all redesigned and rewritten in Python. That worked a lot better. But we started to have a few problems with it. In particular, in 2005, I thought computers had been getting faster for a long time. I thought Python wasn't going to be a problem. Pretty soon it was going to be incredibly fast. And computers had stopped getting faster and they started getting smaller. And now people want to run 0install on their mobile phones and things, which is a problem. Also, we were using it for largish desktop applications that took a while to start anyway, and it was a small overhead, but it didn't really matter. Now people want to run very small utilities that are used in scripts and things, and this was more of a problem. Secondly, we had some reliability problems. We have to integrate with lots of different systems. We have quite a lot of features now. Python, of course, has no static checking. But in particular, the Python 3 change has caused us a lot of trouble. We work with Python 2 and Python 3, and we have, I think, 70–80% unit test coverage. But even so, that's still quite a few things that can break. And we don't unit test the GUI because that's really hard. So in 2013 I had a bit of time and I started trying to find a new language to implement it in. And I asked on the mailing list for suggestions because I really didn't have any strong opinion on what to do. I'd heard about Rust and I was quite excited about that. I read the tutorial, I wanted to see how mature it was. One of my friends had told me about this thing called dependent types, and I found ATS, and that seemed really fascinating, although baffling. So I wanted to try that. One of our other developers, Tim Cuthbertson, a few months earlier had already done some prototyping in Haskell to see if he could write a Haskell version. Go obviously is being pushed heavily by Google. The C# with our Windows guy, the main guy, Bastianica, he does a Windows front end that integrates with all kinds of features on Windows, and that's all written in C#. So he was very keen that we should standardize on C# everywhere. And then some guy I'd never heard of, called Egrex, said, and test OCaml as well. So I did, and I did a lot of tests. This is just one graph. By the way, it said speed. This is speed of startup time, which is the only time we care about in 0install. And OCaml did surprisingly well. Yes. So first impressions, I thought actually were a bit negative. You want to try OCaml, you type OCaml, you find there's no readline support. Syntax errors are quite frustrating for beginners. Python says syntax error at line 300. There is an error at line 300. OCaml was an error in the first 300 lines. But there's some really good points as well. Surprisingly fast, I wasn't expecting that. It's been really reliable, very few bugs in it. Mature, doesn't change fast, and that's great because we need to get the package into lots of distributions, and Debian was on OCaml 3 until quite recently, for example. It's great we could support both at the same time. It's great that it has so many features as direct equivalents to things in Python, so I felt very confident that I wasn't going to get stuck. If I have a class in Python, I can have a class in OCaml, even if you might not like that, but it can do it. And the compiler's very obvious. It's obvious how it works. You're not going to get stuck with some performance problem that you can't figure out. One suggestion I would make, when I go to the OCaml website, and it's better now than it was, but it's quite hard to see why you should stay there, why you should read it. If you look at the list of features, it says it has functions, it has garbage collection, it has objects, it has polymorphism. I'm a Python programmer, I already have all those things. And I generally can divide everything on the list into things I already have and things I don't understand. And it'd be quite nice just to have a page, OCaml for Python users. And you can talk about, look, here's some Python code, here's some OCaml code. The OCaml code runs 100 times faster, and it's the same length. If you want to impress Java users, you can talk about startup time and memory usage. Really hard to write small utilities in Java, because the overheads just kill you. And null pointer exceptions. And just some things just to hook people in and show cool stuff like polymorphic variants, functors, abstract types that we tend to hide from beginners. Even if you don't understand it, just knowing there's some cool stuff there that you might want to stick around and learn, I think would be quite useful. The actual report itself, I didn't want to have a separate OCaml version, so I just started adding OCaml to my Python code. I had the two parts talking to each other via JSON, and that worked really well. It meant that we could release the OCaml version with OCaml just after a few weeks, and already it was faster and people could see some benefits. And it meant we could have the unit tests passing at every point in the process, and we could see the progress. So this graph, the dark blue is Python, the light blue is OCaml. A couple of months just getting up, sort of building support libraries in OCaml, and from there on it's pretty much linear until Python is gone. And the way I did it, which I think worked well, was to just translate everything literally. Just take a Python class and make it into an OCaml class. Once it's in OCaml, as we all know, OCaml is very pleasant and easy to refactor. It's very safe and nice. Refactoring while it's in Python, or trying to refactor at the same time you're translating, is really hard. And the results, the surprising one I think was the lines of code. That was, you expect a static language is going to be longer. You're going to pay some overhead for that, and we didn't. It was actually very slightly shorter, but basically the same length, which is awesome. About 10 times faster in macro benchmarks, running actual complete runs from start to finish. Very reliable, excellent community. I had so much help on my blog and on Stack Overflow. It's been great. And finally, I leave you with some feedback from one of the other developers, the Haskell guy, who said he actually found it easier when he started looking at the OCaml version, easier to add a feature to the new OCaml code than the old familiar Python code, even though he only started using OCaml when I started using it for 0install. Thank you. Time for questions, or do we? Okay. Yeah.
I've found when using OCaml that large packages like clock, for example, sometimes you need to have several incompatible versions installed at once. Is your package sophisticated enough to know when it's got to install an older version of OCaml before or an older version of OCaml to sort of suit a version of clock?
So, in general, I would recommend you use OPAM for compiling OCaml code and not 0install. 0install works very well if you have reasonable binary compatibility of libraries. So if you have C code, Java code, Python code, yes, use 0install to handle dependencies because it can keep things isolated and it can use the right versions. OCaml, because every time you upgrade one library, you have to recompile everything that depends on that library, and then everything depends on that. That I find doesn't work so well with 0install, and use OPAM. Basically. Other questions?
Maybe just a comment. So
Yeah.
Welcome home.
Thank you. Yeah.
If I want to update, for instance, OpenSSL, because there is some security there, and it has been maybe installed several times, right, or several requirements.
Mm-hmm.
Is it easy to do?
Sure, it'll happen automatically. I mean, when you run a program, every so often in the background, 0install will check for updates. And typically your distribution, it'll use the distribution copy anyway, so that's fine. But even if it's getting it from 0install, after a while it will download a new version. That'll just happen by itself.
Why if you really want to force it?
If you force it, then of course it won't upgrade, but then that's kind of the responsibility of...
Force it to go up.
Yeah. I mean, ordinarily, if it's a security bug, they will flag it in the metadata as this version is insecure, and then that will force the solver to use the new version by default. But as I showed with OCaml, you can always force a new version if you want. You can, say, make a new version preferred.
And you rebuild the things, the dependencies towards the applications. Like it's a dependency by deep down. It updates that, and we update the things that.
It works the other way around. It always starts from the application. So from time to time, it will recalculate what the application needs, and it will look down and say, oh, this application that I am updating now, I'll upgrade it SSL. Another application, it might detect that another time. It won't necessarily be in sync. Yeah.
So presumably when you're reporting Python code to OCaml, you do like a literal translation of something to OCaml, and then find that it doesn't type check anymore, but the compiler doesn't accept it. So I'm wondering, how often did this happen? And of the times that it did happen, how many of them were bugs in the Python code, and how many of them were just the OCaml compiler didn't understand what you were doing?
Very rarely. The only time I really couldn't get the OCaml to understand what I was doing was in the SAT solver, where I attach things of particular types to particular SAT variables, and I say, okay, you must select some version of OCaml. And that's a clause. And when I ask it at the end, okay, which version did you select? It says this variable. I know that variable is attached to a version of OCaml, and the user data must be OCaml. But I got so lost with covariances and queues. I asked on Stack Overflow, and it didn't seem to be a particularly clear answer. But that's one case. Apart from that, it wasn't really a problem. A few problems not handling nulls and nuns correctly, as you would expect. With the networking, I was able to make the error handling much more robust and say you must handle every possible network error at every point in the code. I think it's more robust to errors. That's the main thing. But I didn't have any big problems. It wasn't a problem. Yeah.
Can we consider writing the translation script which other people can reuse?
No, I was trying to learn OCaml, so that wasn't a good time to be writing a script. Yeah.
Did you later get rid of the objects, or are they still there?
Yes, I'm slowly going through it. Well, it's a nice, relaxing thing to do in the evening when you're a bit bored. I'm currently changing the solver and turning it into a functor and abstracting the types and things like that. Some things are becoming mutable that were previously mutable. Yeah, I'm slowly doing that. It's why the OCaml API actually isn't quite stable yet. If you want to use 0install from a script, use the command line API or the JSON API, which are both stable. Don't use the OCaml API yet. I'm still fixing it.
Using the same solver used by OCaml?
Yes, our solver is actually, well, I really wanted to make it compatible with the Python version, first of all. I wanted it to get the same results. The solver actually is not that complicated. It's a SAT solver. I converted it in one day. It's just not a problem. Having it in process in OCaml is really nice and easy. We don't need high performance. When you solve with OCaml, you're asking it to find compatible versions over 1,000 packages. Because 0install isolates every program, you're asking it to solve over 10 packets. So it was fast enough in Python. So we don't need the performance, and it's just easier to convert it.